All right, so there's a couple aspects of this question that I didn't really want to rush through in the previous video. So I talked about the curling stone is heading, the acceleration is given north, travels 28 meters. So we got to be careful here. We do have to do a conversion. So it doesn't matter where you do it here. I'm just going to go down below. Delta D would equal, I'm going to multiply that by 100 to get it into centimeters. That's still going to be south. V1 is what I want to know. I want to know what the initial velocity was. So I have two pieces of information. I need a third. So hopefully a bunch of you out there are saying, hey, you know the final velocity of this stone is 0 meters per second. It's come to rest. All right, it doesn't matter the direction we pick here. We'll say north because it comes to rest. Comes to rest. So that being said, we have all the information. Now below, I'm going to get in the habit of identifying my positive direction here. So I'm going to say that, for argument's sake, I'm going to say that south is my positive direction. So that means anything that's south is a positive value in the formula. Anything that's negative, or north, will be negative. So I know A, D, and V2. So there's only one formula that will work here. That's my V2 squared equals V1 squared plus 2A delta D. So V2 squared is 0 squared. V1 is what we're looking for, plus 2. My acceleration was north, so I'm going to enter it as -5. And my delta D, my displacement, was 2800, and it's positive because it is in the south direction. So now we end up solving this. So we end up with 28,000. I guess I'll show a couple extra steps here. Don't want to lose everyone on the first day. So 28,560. Moving that to the other side, or adding 28,560 to both sides, allows me to isolate V1. Taking the square root of both sides, V1 is, let's call it 169 centimeters per second. It's a positive answer. So positive answer means it's in my assumed positive direction. So it will be south. All right, so therefore, initial velocity is 169 centimeters per second south. Okay, moving along. Acceleration due to gravity. So what do we know from 3U? So that is usually a discussable item. However, you're not here to discuss it with me. So I'm going to clarify a couple of things for you. Acceleration due to gravity is defined as the acceleration of an object falling vertically toward the Earth's surface. All right, so that is point 1. Point 2, move this down a little bit. The value of acceleration, g, I'm going to put an arrowhead on top of that, g, varies depending on the mass of the object and the location of the object above the Earth's surface. So, from grade 11, we used this formula once. Gravity was equal to, or in one section I should say, gravitational constant, m1, m2, actually I'm going to use lowercase, m1, m2 over r squared. So m1 and m2, the masses of objects. And your r is the distance between objects. All right, and then g is gravitational constant, which I will provide on tests, since I provide you with all the constants or necessary information. You're responsible for formulas. So that's why gravity varies, is because our distance between our bodies and the center of the Earth vary depending on our elevation on the planet. So that's why our gravity ranges from, say, 9.79 to 9.85 on Earth. So the generally accepted value for our course, and I said this in the opening video, I'm going to use 10 meters per second squared. Definitely not because it's accurate. A, it's an easy number to work with, and B, it is a safety factor. So for all the aspiring engineers out there, You've got a safety factor built right in. All right. So, dealing with gravity. Ball is dropped off a 15-meter high rooftop. Determine the impact velocity. So there's going to be information that's provided. So obviously the ball, its displacement is 15 meters and down. And we want to know impact velocity, or it's our final velocity, V2. So we must know some other information that's inferred. So this is a question where the information that you need to finish is inferred. So you need to figure that out. Well, if something is falling, gravity plays a role here, or acceleration. And I guess I'm going to switch back to A because our formulas use A. I don't want to get too confusing here. And we know that that's 10 meters per second squared, and it's down. And if it's dropped, that means that someone was holding the ball over and just opened their hand and let it fall. So the initial vertical velocity was 0 meters per second, and the direction doesn't matter. So there we are. We have our pieces of information. We have 3 pieces, so we can find a 4th. Again, just decoding, going back to your formula sheet there, you need to discern or use the correct or the appropriate formula. So we are looking for V2 this time, final velocity. V1 was 0, 2AD, both, and again, I'm going to assume down is positive, so acceleration is 10, and that displacement's 15. So V2 squared equals 300. So we end up with a V2 of, what did I do there? 17, around 17 meters per second. I'm kind of doing this off the top of my head. I don't have a calculator handy, so may want to check it just a little bit. Actually, be a little bit higher than 17, 17.3. Close enough. Meters per second down. So therefore, impact velocity is 17.3 meters per second down. All right, so be careful in the grade 12 course. There's a little bit more inferencing required to be successful. So now I have a ball being thrown with an initial velocity. So the initial velocity, it's 8 meters per second up. So I have a V1. 8 meters per second up. If we ignore air resistance, which we're going to do for the most part in this course, we're going to work in a physics world. Determine maximum height of the ball and the length of time for the ball to reach that height. So remember, if we throw a ball upward, and it's going to follow the same path, right? So if here's the ground, we throw the ball up, and I'll just move it over. Here's that max height that the ball will reach. All right, so that would be delta D max. So what other information do we know? Well, again, we know gravity or acceleration is 10 meters per second squared downward. And the question I get you to answer in class would be, at that height, at that max height, how fast is the ball traveling? So right at that pinnacle, or at the absolute top, it's moving upward, it comes to a stop, and then starts falling backwards. So we know at max height, V2 is 0 meters per second. And we are looking for delta D. So again, we seem to end up using that formula again. The V2 squared equals V1 squared plus 2A delta D. I'm going to assume, and it doesn't really matter here, I'm going to assume down as being positive, just to change things up a little bit. So V2 is 0. V1 is going to be negative 8. And I did the substitution with brackets, just like your math teacher told you in grade 9 and 10. When you do a substitution, use your brackets. Acceleration is downward, so it will be positive. And we're looking for delta D. So we end up with 0 equals 64 plus 20 delta D. Negative 64 equals 20 delta D. If we divide both sides by 20, what do we end up with? So that would be 32, so negative 3.2 meters. And our answer always results in the positive or the assumed direction. So I have a displacement of negative 3.2 meters. It's negative, so that means that if I want to correct this, I can rewrite it as a positive 3.2, but I have to switch the direction. So it's okay to get negative answers. In physics, the majority of the time you're spending is dealing with interpretation of your results. So even though the answer is negative, it always, and I'll stress this again, here I said down was positive. So whatever answer gets spit out, it will be in terms of my assumption. If the answer is negative, I can make it a positive, just got to switch that direction. So therefore, max height will be 3.2 meters, and I guess I will put the vector in there, up. Most people are going to assume that you're telling this to. If you told someone max height was 3.2 meters down, they'd think about it. Look at you a little bit funny, but that's the way it is. So there we go. Questions with that, and the majority of your battle will be dealing with sign convention. You need to be very careful, making sure positive and negatives get substituted properly and making sure you enter it into your calculator. So you need to be very aware of that. There's the assigned homework for this first section. I've got the answers here. I'm not sure why, whether the textbook answers are incorrect or not available. But anyway, there they are. Those are the answers for those questions. So you can check your work. If you have any problems, if you want anything to be discussed or gone over, please ask in class and we will get it straightened up. Good luck.